So if we have a matrix A, let's say this is a matrix A, the inverse of this matrix would be written as A to the power of -1. Now this here indicates that it's the inverse of A. The -1 indicates that it's the inverse of A. Now, in order to find the inverse of a matrix, we're combining two things that we learned in our previous video, which would be the determinant of a matrix. So in this case, we would have 1 over the determinant of A. So 1 over the determinant of A, and yes, it's always 1 over the determinant, and we have to multiply that to something we learned in another video, the adjoint of A. Okay, so then once we have the inverse of a matrix, what we would actually do is use that information in order to help us to calculate and solve problems. There are reasons why we use the inverse of a matrix. One of the reasons is because we do not divide in matrices, we only multiply. So if we want to reverse the process of multiplication in matrices, we have to find the inverse and multiply it. So in essence, finding the inverse of the matrix and then multiplying it is the same as almost dividing it, but we're using the principle of multiplication. So just in case we forgot, the determinant of A can be represented as A times D, as I say crisscross, take away B times C. So you'll have A times D minus B times C. Now, as it relates to the adjoint of a matrix A, from our last video, what we learned is we would swap the A and the D. So the D would come here and the A would go here. B, we would change the sign of that, and the C, we would also change the sign of that. Okay, so this is what the adjoint represents, and this is what the determinant represents. Now, what we're going to do is we're going to actually try to find the inverse of some matrices so you can see how this applies in principle. So we have matrix S below. What is the inverse of matrix S below? So based on what we had from our earlier explanation, the inverse of S would look like this, and we would have it as 1 over the determinant, and we're multiplying that to the adjoint of S. So in order to find the inverse, let's look for the determinant of S first. So the determinant of S would be 4 times 7. Remember, we do the crisscross, 4 times 7. So 4 times 7 minus -6 times 3. So -6 times 3. So then we would have here 4 times 7 is 28, and then we have minus -6 times 3 gives us what? -18. So then we'll have here 28, take away -18, which will turn to plus. Just because of these two negatives, it will turn to plus 18. So this here would give us 46. So our determinant is 46. Now our adjoint, so the adjoint of S, what we will have here now, we swap the 4 and the 7. So the 7 would come here and the 4 would go here. We change that -6 to +6. Okay, and then we change that 3 to a -3. So now we can write the final answer for our inverse. So S inverse can now be written as 1 over the determinant, which is 1 over 46. And then we put in that next to, or multiplying it to, the adjoint of S. So we have the adjoint here, which is 7, 4, 6, -3. All right, so this would be our answer here. Notice how I found the determinant first, which is 46, and then I found the adjoint. Now sometimes what some people do, they would find the adjoint first, then the determinant, but instead of using the determinant of this, they find the determinant of the adjoint, which sometimes creates problems. So you have to be careful. Follow this order that you saw here, so you can always try to be spot on with what you're trying to work out. So we can just have our answer here as S inverse is 1 over 46 times 7, 6, -3, 4. And typically we just leave it like this until we have to use it to solve an answer. So matrix T is a non-singular matrix. What is the inverse of matrix T? I'll take this opportunity to say something. You can only find the inverse of a matrix that is a non-singular square matrix. Now let's break that down. Remember, we did in a previous video what a square matrix is. That means they have the same number of rows and the same number of columns. And non-singular means that the determinant is not equal to 0. All right, the determinant is not equal to 0. So in a later part of this video, you'll see what I'm talking about as it relates to that. But for now, we would say that T inverse is equal to 1 over the determinant of t multiplied by the adjoint of t. So, as I said before, we always try to find the determinant of t. We don't want to do the adjoint first, then mistake and find the determinant of that. So therefore, we'll find the determinant first. Always try to keep this as a practice. So the determinant of t, we do the crisscross again. So 4 times negative 3, always from this direction first. Take away 8 times negative 5. So what we'll have is 4 multiplied by negative 3, take away 8 times negative 5. So what you'll see here is 4 times negative 3 is negative 12. And we're subtracting 8 times negative 5. So a positive times a negative is a negative. So 8 times negative 5 is negative 40. So we'll end up with minus 12. And then the minus and the minus will give us plus 40. So we'll end up with 28. So negative 12 plus 40 is 28. So our determinant is 28. Now for our adjoint, the adjoint of t, the adjoint of t. So what that would be equal to now, we swap the 4 and the negative 3. So we'll have the negative 3 here, the 4 here. We'll change that 8 to a negative 8. Remember, we just change the signs of these two. We swap these, but we change the signs of these. We leave them and change the sign. So 8 turns to negative 8. And what do you think negative 5 is going to turn to? Positive 5. So now combining these two, we would say that t, the inverse of t, is equal to 1 over 28, which is 1 over the determinant. And then we'll put the adjoint here, which is negative 3, negative 8, 5, 4. So as you can see here, that's the inverse of t. So we have here that matrix E is a non-singular matrix. What is the inverse of matrix E? So by now you should understand that once it's non-singular, that means the determinant is not 0. So it's either more than 0 or less than 0. So in this case, same concept like before, we say that E inverse would be equal to 1 over the determinant of E, and then we multiply that to the adjoint of E. What do we look for first? You got it, determinant of E. So then we'll do the crisscross again, same process, 7 times 4, and what are we going to subtract it by? Negative 5 times negative 2. So by now you should be a professional at doing this. So 7 times 4 is 28, and we are subtracting. So now we have negative 5 times negative 2. A negative times a negative is a positive. So that would give us positive 10. So we'll be left with 28, take away 10, which is 18. Now the adjoint of E. Adjoint of E. So in this case now, remember what we do. We swap the 7 and the 4. So 4 goes here. 7 goes here, and then we have negative 5 here, negative 2. What happens with those? We change the sign. So the negative 2 turns to positive 2, and the negative 5 turns to positive 5. So now we can actually finish this question by saying the inverse of E is actually equal to 1 over the determinant of E, which is 18, and we put next to that now, or multiply by that, the adjoint of E, which is 4, 5, 2, 7. And that's our answer. So if you look at this question now, it says, what is the inverse of matrix N below? So the first thing we have to do, you know this routine now, we have to find the inverse. And then we multiply that to the adjoint of N. Now in this case, the determinant of N would be 4 times 3 minus 6 times 2. So 4 times 3 is what? 12. Minus 6 times 2, which is 12. Now if you look at this, look at what we have. 12 take away 12, which is 0. What do we call a matrix that has 0 as a determinant? We call that a singular matrix. And we say that a singular matrix does not have an inverse. So in this case, matrix N does not have an inverse because it is a singular matrix. Now let's just say we were to play this out. We would end up having the inverse being 1 over the determinant, which is 0. And we would have that multiplied to whatever the adjoint was. So just to do that quickly, it would have been 3 here, 4 here, and you got it right. We change the signs here. Now look what happens when we put 1 over 0. If you put that into your calculator, you will get a maths error. So as a result of that, that is why we say that this here, matrix N, because it's singular, it does not have an inverse. So that's a little additional note, a food for thought for you, and something that can be used to apply in questions that trying to see if you really theoretically understand what is going on. So as I always say, keep working hard, keep pushing, keep putting your best foot forward, never give up, just continue to walk towards getting better and better at this subject. This subject is a lot about practice. The more you practice, the better you get. So you got to keep at it, stick with it, and you'll see yourself grow and get better than you were the day before.